StepWise is a tool that allows you to write proofs and have them checked at each step to make sure that they're correct. Let's use it to construct a predicate logic proof. Assume the following premises. Anyone who is sleep-deprived or simply crazy acts strangely. Anyone who's a student is sleep-deprived. Anyone who attends UT is a student. Kelly attends UT. We want to prove that Kelly acts strangely. We need to start by defining a set of more concise symbols that we can use to encode these claims. So let SD mean sleep-deprived, SC for simply crazy, AS for acts strangely, AUT for attends UT, and ST for student. So now our problem is this. We want to prove AS of Kelly. Let's use StepWise to do that. So here's our problem set up. We have 4 premises. For all x, if you're sleep-deprived or simply crazy, you act strangely. For all x, if you're a student, you're sleep-deprived. If you attend UT, you're a student. And then we have a specific claim that Kelly attends UT, and we want to prove that Kelly acts strangely. So the first thing that we notice is that we want to reason about Kelly. We have 3 premises that tell us universal claims, and so what we're going to want to do is to start by instantiating them so that they tell us something specifically about Kelly. We're going to apply universal instantiation to create a claim about Kelly specifically. If I click here and double-click here, the premise is copied in. I remove the quantifier, including the closing parenthesis, and then I replace each instance of x with Kelly. First one and second one. Now I should have a particular claim about Kelly. Sure. So now I have that if Kelly attends UT, then Kelly is a student, and Kelly does attend UT. So let's take 4 and 5, apply modus ponens, and derive a new claim about Kelly. All right, and now remember that StepWise left our last claim right here ready for us to work with, and it's easy. All we do is delete this part, and we have a claim that Kelly is a student. All right, now what? Well, premise 2 tells us that anybody who's a student is sleep-deprived. So let's instantiate that to tell us something about Kelly. So anybody who's a student is sleep-deprived. We'll use universal instantiation and get a specific claim about Kelly. Let's delete that. Again, let's click here to get the claim. We remove the quantifier. Note that I can type Kelly or I can click on Kelly here. Either way, let's try that. And we messed up. We forgot to get rid of the closing parenthesis, so that's not a problem. We just go here and we get rid of it and we try again. All right, so now we know that Kelly being a student would imply Kelly being sleep-deprived. Well, Kelly is a student from line 6 here, so we can conclude sleep-deprived using, again, modus ponens. So let's do that. We're going to use 7. And remember that if we use a rule that takes 2 inputs, it does not matter what order we put them in. So that order works fine. Modus ponens. And now we just delete this part, and we have the claim that Kelly is sleep-deprived. All right, what next? Well, what we know next is premise 1. If you're sleep-deprived or you're simply crazy, then you're going to act strangely. Kelly's sleep-deprived. We don't know anything about acting crazy, but if one or the other of these is sufficient to imply the conclusion we need, surely one of them is sufficient. But how can I use the rules to conclude that? What we're going to want to do is to say, well, if Kelly is sleep-deprived, then Kelly or anything must also be true. We can add additional disjuncts. So let's do that. We're going to say Kelly is sleep deprived. And let's say we haven't a clue what rule allows us to do that. Let's turn on the funnel. We'll only see the rules that apply in the current case. And let's look at them. Now, we know that we actually need to use a Boolean rule. Although we're working in predicate logic, now that we've gotten rid of the quantifiers and the variables, SD of Kelly is functioning simply like P. So let's look at the Boolean rules that we've got. And let's look at the inference rules. And here's one called addition. That seems like it might be right. It's going to add another piece. So let's try it. But let's look at the book. It tells us that from P, you can infer P or Q. Well, that's exactly what we need to do for some Q. And in fact, we can use the wrench if we want to see exactly what we might get here, namely Q or SD of Kelly, actually in either order. Well, that's exactly what we want. So let's apply addition, and let's assert SD of Kelly or SC of Kelly. Remember that we don't actually know anything about Kelly being crazy, but it doesn't matter. And sure enough, that's okay. Well, now we have SD of Kelly or SC of Kelly. Now I could use 1 to conclude that Kelly acts strangely, but first I have to instantiate 1 to tell me something specifically about Kelly. So let's take premise 1. Let's use universal instantiation one more time. Let's get rid of that. And we clear out the quantifier, including the final parenthesis this time. And we replace each instance of x, of which there are now 3, consistently with Kelly. And one more. Kelly. So this claim is true specifically of Kelly. Great. All right, now we have that if this antecedent is true, so is the conclusion. The antecedent is true. It's what we established there on line 9. So let's put 9 and 10. We will use modus ponens. Okay. And we derive acts strangely of Kelly. And we're done.